All right, so what's up, everyone? David here, and today we're diving deep into something that honestly powers pretty much everything you interact with online. We're talking about the programming languages that build the web. This is going to be your complete guide, a foundational look at the tools that developers use to create the websites and web applications you use every single day. Whether you're just curious, thinking about a career change, or maybe you're a budding developer looking to solidify your understanding, this video is for you. We're going to break down the essentials, language by language, so you get a clear picture of what each one does and why it's important in the grand scheme of web development. Over the next little while, we'll explore the most important programming languages that form the backbone, the aesthetics, and the interactivity of the internet. Think of it like understanding the different materials and tools a master craftsman uses. Each has its specific purpose, its strengths, and its place in the workshop. From the basic structure of a web page to the complex server-side logic that makes dynamic content possible, we're covering the key players. You'll learn not just what these languages are, but how they fit together to create the seamless experiences we often take for granted. My goal here is to give you a solid, comprehensive overview. We're not just scratching the surface, we're aiming for that deeper understanding. By the end of this, you should have a much clearer roadmap of the web development landscape, especially concerning the languages that make it all tick. So grab a drink, settle in, and let's get into what makes the web work, starting with the absolute fundamentals. Let's go. Alright, so first up we have HTML, and if you're going to talk about web development, HTML or hypertext markup language is absolutely where you have to start. It's not really a programming language in the traditional sense, like one that performs logic, but it's a markup language. Think of it as the literal skeleton of every single web page you visit. Without HTML, your browser would have no idea how to structure the text, the images, the links, or anything else you see on a page. It provides the fundamental framework, the bones upon which everything else is built. Essentially, HTML uses a system of tags to define different elements on a page. You'll have tags for headings, paragraphs, images, links, lists, tables, and so much more. These tags tell the browser, hey, this piece of text is a main heading, or this here is an image, and here's its source. It's this structured information that allows search engines to understand your content and accessibility tools to interpret it for users with disabilities. It's the universal language that all web browsers understand for displaying content. When you're creating an HTML document, you're essentially building a tree-like structure. You have a main tag, and inside that, you'll typically find a section for metadata and a section where all the visible content resides. Within the body, you nest other tags to organize your content. For example, you might have a A for navigation links, and for the main content, and A. This semantic structure is crucial for modern web development. The beauty of HTML is its relative simplicity to get started with. The syntax is straightforward, and you can start creating basic web pages with just a text editor and a browser. You define an opening tag, like for a paragraph, put your content inside, and then close it with a closing tag. Of course, there are nuances and best practices to learn, especially with HTML5, the latest version, which introduced a host of new semantic elements and APIs, making web pages even more powerful and well-structured. Understanding HTML is non-negotiable for anyone even remotely interested in web development. It doesn't matter if you want to be a front-end developer focusing on what the user sees, or a back-end developer working on server-side logic, or even a designer who needs to understand how their designs will be implemented. A solid grasp of HTML is the first essential building block. It's the common ground, the starting point for every single website out there. Think about any website you visit, from a simple blog to a complex e-commerce platform or a social media giant. Underneath all the fancy styling and interactivity, there's an HTML structure holding it all together. It dictates where the logo goes, where the navigation menu sits, how the articles are laid out, and where the comments section appears. This structural integrity is paramount before you can even think about making things look pretty or function dynamically. So when we say HTML is the backbone, it's not an exaggeration. It's the core content structure. It's what gives meaning and order to the raw information presented on the web. Learning to write clean, semantic HTML is a fundamental skill that will serve you well throughout your entire web development journey. It's the first language you should tackle, and thankfully it's also one of the most accessible to pick up and start seeing immediate results with. And that's the thing about HTML. You can see your work come to life very quickly. You write a few lines of tags, save the file as open it in your browser, and boom, you've created something. This immediate feedback loop is incredibly rewarding for beginners and helps build confidence as you move on to more complex aspects of web development. It's the quiet, unassuming hero of the web. All right, so once you have your HTML structure in place, that skeleton we just talked about, the next step is to make it look good. And that's where CSS, or cascading style sheets, comes into play. If HTML is the bones, then CSS is the skin, the clothes, the hair, the overall aesthetic presentation of your web page. It's responsible for everything from colors and fonts to layout and responsiveness. Without CSS, the web would be a very bland, very utilitarian place, just black text on a white background, like documents from the early 90s. CSS allows you to take that raw HTML structure and apply styles to it. You can select HTML elements based on their tags, classes, IDs, or other attributes, and then define how they should look. Want to make all your headings blue in a specific font? CSS does that. Need to arrange your content into columns, add spacing between elements, or create complex visual effects? That's all CSS. It's an incredibly powerful language for controlling the presentation layer of a website. The cascading part of cascading style sheets is also really important. It refers to the way styles are applied and how conflicts are resolved. You can have multiple style sheets, and styles can be inherited from parent elements to child elements. CSS has a specific set of rules, the cascade, that determine which style rule applies if multiple rules target the same element. Understanding this specificity and inheritance is key to mastering CSS and avoiding frustrating styling bugs. One of the biggest strengths of CSS is the separation of concerns it enables. You keep your content structure in your HTML file and your presentation rules in a separate CSS file or files. This makes your code much cleaner, easier to maintain, and more scalable. Imagine having to define the font and color for every single paragraph tag directly in your HTML. It would be a nightmare to update. With CSS, you define it once in your style sheet, and it applies everywhere. Or you can change it in one place for a site-wide update. Modern CSS, especially with advancements like CSS3 and beyond, has become incredibly sophisticated. We're talking animations, transitions, complex layout systems like Flexbox and CSS Grid, custom properties, often called CSS variables, and even features that allow for styles based on user preferences like dark mode. These tools give designers and developers an immense amount of control over the visual experience, allowing for truly creative and engaging web designs that adapt to different screen sizes. Learning CSS involves understanding selectors, how you target elements, properties, what you want to change like, and values, the specific settings for those properties, like it's a declarative language, meaning you describe the desired outcome, and the browser figures out how to render it. This is different from imperative languages where you specify step-by-step instructions. And it's not just about making things look pretty. Good CSS is also crucial for usability and accessibility. Proper use of color contrast, legible font sizes, and logical layout contribute significantly to how easily users can interact with and understand your website. Well-structured CSS can also improve performance by allowing browsers to render pages more efficiently. It's a deep field, and there's always something new to learn as the language evolves. So, while HTML gives your web page its structure, CSS is what gives it its personality, its brand identity, and its visual appeal. It transforms a plain document into a polished, professional-looking website. Mastering CSS means you can take any design vision and translate it into a living, breathing web page. It's the artistic side of front-end development, and it's absolutely essential for creating modern, engaging user experiences. So, we've got our structure with HTML and we've made it look good with CSS. But what if you want your website to do things? To react to user input? To update content dynamically without reloading the page? To create interactive maps, games, or complex animations? That's where JavaScript comes in. If HTML is the skeleton and CSS is the skin, then JavaScript is the muscles and the nervous system. It provides the interactivity and dynamic behavior. JavaScript is a true programming language. Unlike HTML and CSS, it runs directly in the user's web browser. It's client-side, though it can also run on servers, which we'll touch on later. This means it can manipulate the HTML and CSS of a web page in real time. You can use JavaScript to show or hide elements, change styles based on user actions, validate forms before they're submitted, fetch data from servers in the background, and so much more. It's what makes web pages feel like applications rather than static documents. Think about common interactions you experience online. Image sliders, drop-down menus that appear when you click, content that loads as you scroll, real-time chat applications, or even just a simple alert message popping up. Most of that is powered by JavaScript. It has access to something called the Document Object Model, or DOM, which is essentially a representation of your HTML structure that JavaScript can read and modify. The power of JavaScript lies in its ability to respond to events. An event could be a mouse click, a key press, a page loading, a form submission, or even a timer going off. You write JavaScript code that listens for these events, and when an event occurs, your code executes a function to do something in response. This event-driven programming model is fundamental to how interactive web experiences are built. It's what makes the web feel alive. For many years, JavaScript was primarily a front-end language, but with the advent of Node.js, it can now also be used for back-end development, allowing developers to use a single language across the entire web stack. This has significantly boosted its popularity and versatility. However, its core strength and primary use case still revolve around enhancing the user interface and user experience in the browser. Learning JavaScript involves understanding variables, data types, operators, control flow like if-else statements and loops, functions, objects, and asynchronous programming. Asynchronous programming is particularly important for web development, as it allows JavaScript to perform tasks like fetching data from a server without freezing the user interface. Concepts like promises and async await are key here. The JavaScript ecosystem is vast and constantly evolving. There are countless libraries and frameworks built on top of JavaScript to make development faster and more organized. You've probably heard of names like React, Angular, and Vue.js. These are popular front-end frameworks that provide powerful tools and conventions for building complex user interfaces. But even to use these frameworks effectively, a solid understanding of vanilla JavaScript is essential. So to recap, HTML for structure, CSS for presentation, and JavaScript for behavior. These three are often called the holy trinity of front-end web development. JavaScript is the engine that drives dynamic content, user interaction, and much of what we consider a modern web experience. It's a language that has grown immensely in scope and capability, and it's an indispensable skill for any aspiring web developer looking to create rich, interactive websites. Alright, so we've covered the core front-end technologies. Now let's shift gears a bit and talk about languages that are often used on the back end, the server side of web development. And one of the most popular and versatile languages in this space is Python. You might know Python for its use in data science, machine learning, or scripting, but it's also a very capable language for building web applications. Python's popularity in web development stems largely from its readability, simplicity, and the extensive collection of libraries and frameworks available. Its syntax is often described as being close to plain English, which makes it relatively easy to learn and write, especially for beginners. This focus on developer productivity means you can often build complex applications faster with Python than with some other languages. It's designed to be clean and expressive. When it comes to web development with Python, you'll almost always be using a web framework. Frameworks provide a structured way to build applications, handling a lot of the common repetitive tasks like URL routing, database interaction, and template rendering. Two of the most well-known Python web frameworks are Django and Flask. Django is a high-level, batteries-included framework that provides a lot of built-in features, making it great for larger, more complex projects. Flask, on the other hand, is a micro-framework. It's much more lightweight and minimalistic, giving developers more flexibility and control over the components they want to use. This makes Flask a good choice for smaller applications, APIs, or when you want to integrate specific tools without the overhead of a larger framework. Both Django and Flask have large active communities and a wealth of documentation and third-party packages. Python's role in the back end typically involves handling requests from the front end, the user's browser, processing data, interacting with databases, managing user authentication, and then sending back responses, often in the form of HTML, CSS, and JavaScript, or data formats like JSON. It's the logic behind the scenes that powers the website. For example, when you submit a login form, Python code on the server might verify your credentials against a database. Beyond Django and Flask, there are other Python web frameworks like FastAPI, which is gaining popularity for building high-performance APIs, and Pyramid, which offers a balance between the minimalism of Flask and the comprehensiveness of Django. The choice of framework often depends on the specific needs of the project, team familiarity, and the desired level of control versus convention. One of Python's significant advantages is its vast standard library and the Python Package Index, or PIPI, which hosts hundreds of thousands of third-party packages. This means that for almost any task you can imagine, from image processing to data analysis to network communication, there's likely an existing Python library you can use, saving you significant development time and effort. This ecosystem is a huge draw for developers. So if you're looking for a powerful, readable, and versatile language for back-end web development, Python is definitely one to consider. Its strong community support, excellent frameworks, and suitability for a wide range of applications, from simple websites to complex enterprise-level platforms, make it a very attractive option. Many large companies like Instagram, Spotify, and Dropbox use Python extensively in their tech stacks. Next up, let's talk about a language that has been a cornerstone of server-side web development for a very long time, PHP. PHP, which originally stood for Personal Homepage and now stands for PHP Hypertext Preprocessor, a recursive acronym, which is kind of neat, is a scripting language specifically designed for web development. It's been around since the mid-90s, and despite the rise of newer languages, still powers a significant portion of the web. One of the main reasons for PHP's enduring popularity is its deep integration with web servers and its ease of embedding within HTML. You can literally write PHP code directly inside your HTML files, enclosed in special tags. When a user requests a page, the web server processes the PHP code, executes any logic like fetching data from a database, and then sends the resulting HTML to the user's browser. This makes it very straightforward to create dynamic web content. Perhaps the most famous application built with PHP is WordPress. WordPress is a content management system, or CMS, that powers a huge percentage of all websites on the internet, from personal blogs to large corporate sites. If you've ever used WordPress, you've interacted with a system built almost entirely on PHP and MySQL. The success of WordPress alone has ensured PHP's continued relevance and a massive community around it. Beyond WordPress, PHP is also the foundation for other popular CMS platforms like Drupal and Joomla, as well as e-commerce platforms like Magento. There are also robust PHP frameworks like Laravel and Symfony, which provide modern development practices, tools, and structures for building sophisticated web applications. These frameworks have helped PHP evolve and stay competitive in the modern web development landscape. PHP's strengths include its relatively gentle learning curve for web-specific tasks, a vast amount of online documentation and tutorials, partly due to its long history and wide availability on web hosting providers. Most hosting companies offer PHP support out of the box, often at a very affordable price, making it easy to deploy PHP applications. This low barrier to entry has always been a significant factor in its adoption. Over the years, PHP has undergone significant improvements. Modern versions of PHP are much faster, more secure, and include features found in other contemporary languages, like object-oriented programming capabilities, type declarations, and a robust package manager called Composer. These advancements have helped address some of the criticisms leveled against older versions of the language and have made it a more viable choice for new projects. When you're working with PHP on the back end, you're typically dealing with tasks like handling form submissions, managing user sessions and cookies, interacting with databases. MySQL is a very common partner for PHP generating dynamic page content and building APIs. Its focus has always been squarely on the web, which means many web-related tasks are very natural to implement in PHP. So, while some newer languages might get more of the spotlight today, PHP remains a workhorse of the web. Its massive installed base, the prevalence of platforms like WordPress, and the continued development of the language and its frameworks mean that PHP developers are still very much in demand. If you're interested in working with established platforms or need a widely supported server-side language, PHP is a very practical skill to have. Alright, let's move on to another influential language in the web development world, and that's Ruby. Ruby is a dynamic, open-source programming language with a strong focus on simplicity and productivity. It was designed by Yukihiro Matsumoto in the mid-1990s with the goal of creating a language that was enjoyable for programmers to use, often described as developer-friendly. Its elegant syntax is designed to be readable and easy to write. When people talk about Ruby in the context of web development, they are almost invariably talking about Ruby on Rails, or simply Rails. Rails is an extremely popular open-source web application framework built with Ruby. It follows the convention over configuration philosophy and the don't repeat yourself or dry principle, which means it provides a lot of sensible defaults and structures to help developers build applications quickly and efficiently without a lot of boilerplate code. Rails popularized many concepts and patterns in web development, including Model View Controller, or MVC, architecture, scaffolding, and a strong emphasis on testing. The MVC pattern separates the application's concerns into three interconnected components: the model, for handling data and business logic; the view, for presenting data to the user, typically as HTML; and the controller, for handling user input and interacting with the model and view. This organization makes applications easier to manage and scale. The convention over configuration aspect of Rails means that if you follow Rails conventions for naming files and classes, a lot of the setup and configuration is handled for you automatically. This can dramatically speed up development, especially in the early stages of a project. Developers who embrace these conventions often find Rails to be an incredibly productive environment. Ruby itself is a purely object-oriented language, meaning everything in Ruby is an object, even basic data types like numbers and strings. This consistency, combined with its flexible syntax and features like metaprogramming, writing code that writes code, makes it a very powerful and expressive language. Many developers find Ruby a joy to work with because of its elegance and the way it allows them to express complex ideas concisely. The Ruby Gems package manager is another key part of the Ruby ecosystem, providing access to tens of thousands of reusable libraries called gems that can add all sorts of functionality to your Rails applications or standalone Ruby scripts. This extensive collection of gems means you can often find pre-built solutions for common problems, further accelerating development. Websites like GitHub, Airbnb, Shopify, and Basecamp were all famously built with Ruby on Rails, which speaks to its capability for building large, scalable, and successful web applications. While the initial hype around Rails might have cooled slightly, as other frameworks and languages have emerged, it remains a very strong and mature choice for web development with a passionate and active community. So if you're drawn to a language that prioritizes developer happiness and productivity, and you appreciate a framework that provides a lot of structure and sensible defaults, then Ruby and Ruby on Rails are definitely worth exploring. Its elegant syntax and the power of the Rails framework make it a compelling option for building a wide range of web applications, from startups to established enterprises. It's a testament to thoughtful language and framework design. So we've talked a lot about JavaScript and its central role in front-end development, and increasingly in back-end development too. But as JavaScript projects grow larger and more complex, managing that complexity can become a challenge. This is where TypeScript comes into the picture. TypeScript is, essentially, a superset of JavaScript developed and maintained by Microsoft. Think of it as JavaScript with added features, the most important of which is static typing. What TypeScript does is it allows you to add type information to your JavaScript code. In standard JavaScript, variables can hold any type of data, and this can sometimes lead to unexpected errors that are only caught at runtime, when the code is actually running in the browser or on the server. TypeScript, by contrast, allows you to define types for variables, function parameters, and return values. For example, you can say that a particular variable must always be a string or a function must always return a number. These type definitions are checked by the TypeScript compiler during development before the code even runs. This static type checking can catch a whole class of errors early in the development process, making your code more robust and reliable, especially in large code bases with many developers working together. It's like having an extra layer of safety and predictability built into your JavaScript development workflow. The beauty of TypeScript is that it compiles down to plain JavaScript. Browsers and Node.js environments don't run TypeScript directly, they run the JavaScript that TypeScript generates. This means you can use TypeScript in any project where you would normally use JavaScript, and you can even gradually introduce TypeScript into existing JavaScript projects. It's designed for interoperability. Beyond static types, TypeScript also brings other features to JavaScript development, such as support for interfaces, enums, generics, and access modifiers like public, private, and protected. Familiar to those from languages like Java or C#. These features help in writing more organized, maintainable, and object-oriented code. It also often provides access to the latest JavaScript features before they are widely supported by all browsers, as the TypeScript compiler can transpile them down to older, compatible JavaScript versions. Many popular JavaScript frameworks, including Angular, which is written in TypeScript by default, and increasingly React and Vue.js, have excellent TypeScript support. In fact, using TypeScript with these frameworks is becoming a common best practice for building scalable and maintainable applications. The improved tooling, such as better auto-completion and refactoring capabilities in code editors, is another significant benefit that developers appreciate. The learning curve for TypeScript, if you already know JavaScript, is mainly about understanding the type system and how to apply it effectively. It might seem like extra work initially to add type annotations, but many developers find that the long-term benefits in terms of bug prevention, code clarity, and maintainability far outweigh the initial effort. It helps make implicit assumptions in your code explicit. So if you're working on larger JavaScript projects, or if you're looking for ways to improve the reliability and maintainability of your JavaScript code, TypeScript is definitely a technology you should investigate. It's not a replacement for JavaScript, but rather an enhancement designed to help developers write better, more robust JavaScript applications, especially as those applications scale in size and complexity. It's JavaScript, but with a safety net and some extra superpowers. Alright, so that's a pretty comprehensive look at some of the most important programming languages you'll encounter in web development. From the foundational structure of HTML, the styling power of CSS, and the interactivity of JavaScript, to the server-side capabilities of Python, PHP, Ruby, and the enhanced safety of TypeScript, each plays a crucial role in building the web experiences we use every day. Hopefully, this gives you a much clearer picture of what each language does and where it fits in. My biggest piece of advice now is to encourage you to explore these languages further. Pick one that seems interesting or relevant to what you want to build, and start learning. There are tons of amazing resources out there, from documentation and tutorials to interactive coding platforms. The best way to really understand these tools is to get your hands dirty and start building things, no matter how small. Don't be afraid to experiment, make mistakes, and learn from them. That's a core part of the development process. Remember, mastering these tools, or even just getting proficient with a few of them, opens up a truly endless array of possibilities in web development. Whether you dream of building the next big social media platform, a sleek e-commerce site, a helpful utility, or just your own personal blog, these languages are your building blocks. The journey of learning can be challenging, but it's also incredibly rewarding. So thanks for watching. I hope this was helpful, and I'll catch you in the next one. Peace.